Let ABC, this blue triangle, okay, be a triangle of reference, and I'm interested in the following question. What is the locus of inconic centers to ABC? So here's a particular inconic, this brown thing, and here's its center O, right? So I want to know the locus of O such that the Poncelet family interscribed between the circumcircle of ABC and the particular inconic will contain an equilateral triangle. So what does that mean? That means that if, I actually jog through the Poncelet defined by these two conics, the circumcircle and this particular inconic, I want one of the members of this family, for example, this one, to be equilateral. So what Mark Helman derived was that this corresponds to having the center of the conics, of the inconics, lie on the perpendicular bisector of X3 X5 of ABC. So I'm drawing in this red dashed line here the perpendicular bisector, and I'm just sliding O on this bisector while staying within the bounds of the medial triangle so that the inconics remain ellipses, right? And I'm showing here that for whichever place that O might be on this line, I can always find, so let's leave O there, I can always find over that Poncelet family an equilateral. So where is one of the vertices of this equilateral? The vertex of this equilateral is at this point over here, which I can locate with a simple algorithm as well. But you can see here now that this green triangle here is equilateral, and it is within the family of Poncelet triangles defined by this particular inconic and the circumcircle. If I now move O to a different location over here, the family will still contain an equilateral, but now one of its vertices is at a different location. Okay? Now for whichever location of O I choose, in this case within the medial, okay, the X110 of this family remains stable both over O, so it's a double stationarity, and over Poncelet. Okay, now how do I locate the vertex of, how do I locate one vertex of the equilateral triangle? There's only one in this family. So what you do is you measure the angle between the center of the system and the center of your conic with respect to X110 and the center, right? So it's the angle, if you want to state it in simple terms, it's the angle that goes from O to X3 to X10, the fixed X10. You get that angle alpha, and what you do is you actually rotate this line here, X3 to O, a third of alpha, and then when you extend that line, you get the apex of the equilateral. So there's a division by 3. We don't have a synthetic method of doing this. Another thing that I'm showing here is the locus of X5 of the family. And this locus is rather nice. It's a circle. And the circle is centered on O, the center of the caustic. And it passes through X3 and X5 of the ABC reference triangle. Okay, so there you have it. This is our result. The result that we have here is that provided that the center of the inconic to a scalene triangle ABC is on the perpendicular bisector of X3 and X5, the Poncelet family defined by that inconic and the outer circumcircle will contain an equilateral. And that family will preserve the position of X110 on the circumcircle, both over the family as well as over all the inconics that have centers on this line. Okay, so that's all I have. Thank you.